Hi students, so let us now solve question number 9. So here there is a meter scale of length L which is given to be 1 meter. So resting on a hemisphere, solid hemisphere like this. So it's equilibrium right now. So the normal force is balancing the mg of the scale. Now it is slightly depressed and then released. So it starts performing angular SHL, right? So what would be the time period of the oscillation they are asking? So here we will try to find the torque which is responsible for bringing the body back once it has been depressed. And that torque should be equals to, in Newton's second law we write for translational motion F equal to ma. Now we write torque equals to I alpha. So this is a vertical passing through its center of mass. So once you depress this, the whole thing will turn something like this. Okay. So now this is the point which is in contact. So about that point it will try to go back this way. So whatever normal force will act here, the angle by which it has fallen down is theta, let's say. Then since this is tangent to this circle, this should be the radius, right? Radius and tangent are perpendicular. And this line is vertical, this rod was initially horizontal. So this rod and this line are perpendicular, this tangent and this radius are perpendicular, so this is also theta. So when the rod reaches here, this is the center of mass, right? So mg will act this way, mg on the scale. So about this point, this mg will create a torque this way. Normal force will not, because it is passing through that point itself. Let's call that point as O. So torque about O will be equals to mg into r perpendicular. Now for mg, this is your r perpendicular, isn't it? So what will be that? This is your r, so 90 degree, this is theta, so r perpendicular will be r sine theta. Now SHL is always for small displacement, so if the angular displacement is very small, then sine theta can be written as theta. And theta is clockwise, the torque due to this mg will be anti-clockwise, so minus sign will come. Right? So the sense of these two are in opposite direction, so minus. That should be equals to I into alpha. Now the scale is rotating this way, right? So in a way, since it is small oscillation, it is rotating around this point only, around this region. So you can consider this to be center of mass itself. And for a rod about center of mass, what is the moment of inertia? ml square by 12 times alpha. Right? So alpha comes out to be, mass will cancel, 12 gr by L square into theta with a minus. So this is like your acceleration equals to omega square x, except now angular quantities have come. So instead of acceleration, you have angular acceleration. Instead of displacement, you have angular displacement. So this quantity must be your omega square. So the question was to find period of oscillation, right? So the time period will be 2 pi divided by omega. So it will be root over, this is root, omega will be root of this. So if you divide, it will become, here L square will go, here 12, here G, here R. Now let's see what were the given quantities. Radius is 30 centimeter, so it will be 2 pi into L. Length is 1, so 1 square is 1 itself. 12 into 10 into radius is 30 centimeter. 30 centimeter 0.3. So 2 pi root over 1 by 3, 3 to the 6, 36. So this will be 2 pi by 6. So it will be pi by 3 seconds. So which is the right answer? C.